Miss,
Yeah.
I don't get it.
Okay, let me explain again. So, yeah, let me use my pen. See, so for comparing things, we use, suppose there are two girls, Tina and Emmy. Okay, Tina
Okay.
has 8 stickers more than Emmy. Like if Tina is having 32 stickers and Emmy collected 24 stickers, suppose. So we can say that Tina has 8 stickers more than Emmy, and Emmy has 8 stickers less than Tina. They both are correct ways of saying. So using word more than or less than, using these words we compare things, right? Like
Yeah.
I have 5 more pen than you, like this type of these things we talk in class, right, with our friends, that I have 5 more pens than you. So this is just a comparison, right?
Yeah.
So let us find the difference between the cost of car and motorcycle. The other way of comparing is by finding difference, right? Suppose the cost of car is 50,000 and cost of bike is $5,000. So if I find the
Okay.
difference, um, I can say that the cost of car is this much more than the cost of motorcycle, right? Suppose here this is 50,000. If I do 50,000 minus 5,000, I get 45,000, right?
Yeah.
So I can say that cost of car is 45,000 more than cost of motorcycle, right?
Okay.
This is again a way of comparing things, right?
Yeah.
But better way of comparing same thing, if I take same example, I can compare it in a better way. Okay,
Yeah.
how? Let's see. Uh, if I divide them, this is the cost of car and this is the cost of motorcycle. If I divide them, what will I get is 10 over 1. These three zero cancel with these three. 50 divided by 5 is 10, right?
Yeah.
So I can say the cost of the car is 10 times the cost of motorcycle, isn't it?
Yeah.
And this is a better way of comparing things, isn't it?
Okay. Yeah.
Yeah. So this same thing can be written as a ratio. So basically, in certain situation, comparison by division makes better sense than comparing by taking difference. Like in above example, when I was comparing them by subtracting, this was not making that much sense. This was making sense, but if I divide them and I say that the cost of the car is 10 times the cost of motorcycle, this is better way of comparison, isn't it?
Yeah.
And when we compare things by division, this is called ratio. Okay, like here, what I did is this is a car and this is a motorcycle. We divided their price, we got 10 over 1. This same thing can be written as 10 ratio 1, or this is also read it as 2, and this is the symbol of ratio which is colon. That means the price of car is 10 times the price of motorcycle. Like you can see there are 10 equal boxes and one box is representing the price of motorcycle, then 10 boxes are representing the price of car. Is that clear?
Okay.
So there are three ways to represent or to write ratio. Like here, the ratio of orange ball, or let's say circle, with and ratio of orange to green is, because there are three orange, so 3 ratio, there are 4 green, 3 ratio 4, right? Either we
Yeah.
can use colon or we can use word 2. I can say 3 to 4. The ratio of red ball to green ball is 3 to 4. So other ways, right, by writing 2. third is as a fraction, 3 over 4. So there are three ways: using colon, using 2, or fraction. Clear?
Yeah.
Okay. So write the following ratio in three different ways. So ratio of blue shapes to orange. So like here blue is written first. How many blue shapes are there?
Okay.
How many
Uh,
blue shapes are there?
there are one, two,
2. So we'll write 2 first, then we will write colon. How many orange
then
shapes
there
are
are
there?
one, two, three,
So the
then
ratio
there are
is 2 to
circles.
3. Ratio of blue shapes to oranges 2 to 3. Now ratio of total shapes to green circles. So first row total shapes is written. Order is important here. Whatever is written first, we need to check that first. Total shapes are, how many total shapes are there?
So there are one, two, three, four, five, six, seven, eight, nine, 10.
10 shapes. And how many green circles are there?
Okay. So there are one, two, three.
Three green circles are there. One, two.
Oh wait, no.
Yeah, there are only two green, right? One is red. So the ratio of total shapes to green circle is 10:2. Clear? First we wrote
Yeah.
total shapes, then green. What is the ratio of triangle to total shapes? How many triangles are there?
So there are one, two, three,
One, two,
four.
three, four. Okay, four. And total shape we just counted was 10, right? So the ratio of triangle to total shape is 4 to 10. If I write 10 to 4, it would be wrong. We will see why. Why order matter. We'll see that with the help of an example. So far we learned that ratio is comparing by division, right? When we compare two quantities, we can use ratio. So ratio can be of the following types. Ratio can be part to part. Part to part means like this: there is a classroom, there are some boys and girls. So how many boys are there? If you see 1, 2 and 3, right? There are 3 boys.
Yeah.
So 3 boys and girls, 1, 2 and 3 girls, right?
Okay.
So ratio of boys to girl or girls to boys is same, 3 to 3. So this is part to part. Part to part means there is a classroom, and inside
Okay.
a classroom there are girls or boys, and their ratio we are finding. So boys
Okay.
or girls are the part of total students. So this is part to part ratio. Sometimes we find
Okay.
part to whole ratio. So boys are part of the classroom, part of total students, and whole means total. So boys are 3 and total students are, how many total students are there?
Um. So there are one, two, three, four, six.
6. So boys to total ratio is 3 to 6, right?
Um.
So boys is part and total is whole, right? So this is called part to whole. Then the third type can be whole to part. When we write whole first, whole means total. So there are total 6 and girls are 3. 6:3. Okay?
Miss, I don't get it.
Okay. Um, Basically what I'm saying is there are three types of ratio. Okay? Part means part of total student, like boys or girls are the part of total students, right? When we are finding boys and girls ratio, they both are
Okay.
part of total students. Whole means total. When we are finding part to whole, part means boys or girls, their ratio with total students. Total is whole, right?
Yeah. Yeah.
Then ratio is, because we represent sometimes ratio with fraction, but ratio may not represent the same thing as fraction does, because fraction, in fraction all the parts are equal, right? in a whole. Like if I'm dividing a pizza into equal slices, I can write it as a
Okay.
fraction. But in fraction, it is in case of ratio, it is not in like always like that we need to compare equal quantities, equal parts in a whole. Sometimes we compare different parts of a whole, like part of pizza
Okay.
eaten. So part of pizza eaten, one, two, three, four. Four part out of total pizza is eaten, right?
Okay.
So there are total 11 parts, and out of which 4 is eaten. So fraction would be 4 over 11, right? Part of
Yeah.
pizza left. So there are 7 slices left out of 11. So we can say 7 over 11. A ratio compares different parts of a whole. So the ratio of pizza eaten to pizza left. This is what we need to find. So ratio of pizza eaten. How many slices are eaten? 4, right? Right?
Um.
And how many slices are left? 1, 2,
Um.
3,
There
4, 5, 6, 7. How many are left?
7.
So the ratio of pizza eaten to pizza left is 4 ratio 7 or 4 to 7, right?
Okay.
Ratio of pizza left to pizza eaten. So this is the ratio. Whatever is written first, we write that ratio first. Pizza left is 7, which is, and how pizza eaten is, how many slices are eaten?
There are um 4 slices eaten.
So 4. Ratio of pizza eaten to total parts. So eaten is 4 and total parts are,
Okay. Wait.
just check here in the denominator. This is representing total parts, right?
Yeah. 14.
That's 11, okay?
Okay.
So here we are comparing fraction represent equal parts in a whole, but here you can see we are comparing different parts of a whole. Sometimes we are comparing pizza eaten to pizza left or pizza eaten to total. So in ratio it's not necessary. It will compare equal parts of a whole. Now,
Okay.
yeah, the height to width ratio is given, which is 2 to 3. So this is 2 and this is 3. We need to draw a diagram whose height to width ratio is 3 to 2. So you can see we switched it. 2 is written first, 3. But here 3 is written first. So if we switch it, it will look something like this, right? Because
Yeah.
this is 3 and this is 2 now. First, 3, the longer side was 3. But now because we switched it, so it will look like this, right? Because now this is
Yeah.
3 and this is 2.
Okay.
Yeah, so let's say a recipe uses 3 cups of flour and 2 cups of milk to make cookies. Will the recipe remain same if Sarah uses 2 cups of flour and 3 cups of milk instead? So here the ratio of cups of flour to cups of milk is 3 to 2.
Okay.
But here the ratio we switched it. We So will the recipe remain same? What do you think?
Uh, I don't think so.
Yes, it will not remain same. Instead of 2 cups of milk, if we put 3 cups of milk, obviously there would
That's
be a change, right?
yeah, and plus that's too much.
Yeah, so that means in ratio order matters. Like in addition, either we write 2 plus 3 or 3 plus 2, it doesn't matter. In both case, I will get 5. So here in addition, order does not matter, right? But in case of ratio, if we are writing 3 ratio 2 or 3 to 2 or 2 ratio 3, it matters. These two things are not equal, not same, okay? We can
Yeah.
understand with the help of this example. Let's see one more example. So write a ratio comparing number of people to number of pizza for each picture. Can you tell me what is the ratio of number of people to number of pizza. In first
Okay.
diagram, what is the ratio of a number of people to number of
It
pizza?
is 4. So 1, 4.
1 ratio 4. Good. In second one, in second picture,
1, 2, 3, 4. 4, 1.
very good. Are these ratio same? Are they alike? Are they representing same thing? Is it same thing either one person eating four pizzas or four person sharing one pizza? Are these situations same?
Okay. No,
No.
because
That
it's 4 people.
yeah. So you can see when I'm switching the ratio 1 to 4 or 4 to 1, it does not remain same, right? It means different, right? Are you getting it?
Yeah.
So the situation changes if we change the order of pizza and people. So that means the order matters when we are writing a ratio. Is that clear?
Okay.
Yeah. So suppose there is a question, Sam's age is 25 and his father age is 50. How many times is Sam's father older than him? So in ratio we compare by dividing it, right? So father's age, if I divide father's age with Sam's age, father's age is 50, Sam's age is 25. 25 divided by, I mean 50 divided by 25 is 2, right? So 2 over 1,
Okay.
which we can write 2 ratio 1 or 2 to 1. So this is, if this is father's age, this is Sam's age. That means Sam's
Okay.
age is 2 times, Sam's father's age is 2 times as old as Sam's age, right? Because we got 2 1. That means if this is the age of Sam's father and this is Sam's, right? Which is 2
Yeah.
times. Yeah, let's see this question. So cake, there is a recipe for cake. Recipe for one person is this. 2 eggs required, 2 cups of flour and 4 cups of sugar. So it says rewrite the recipe for the given number of people. So recipe for 8 people. Let's start with for 2 people, okay? So if this is for
Okay.
one person, how many eggs would be required for 2 person? This is for one person.
Um. Wait. 2 person. Would there be 4 eggs,
Very good. 2 times
cups
2.
of milk, and 8 cups of sugar.
Exactly. And for 8, just times it with 8, right? Because this is for one person. For 8,
16 eggs,
yes,
16 sugar, and then 32 cups of that.
yes,
Miss, that's
exactly.
too
Yeah,
much. That's too much for.
yeah, but that's for 8 people. So, yeah. Now let's solve some questions based on ratio, okay?
Miss, can I go to the toilet real quick?
Okay, yeah, you can go.
Yeah.